Give you a bit of a flavour of the challenges and opportunities that we're looking at in London with regards to electric vehicles and inductive charging. So I'm going to cover a little bit to do with taxis, vans, issues regarding the power grid in London, and a larger section on buses and a bus project we've got coming up. Okay, with the taxis, with the current scenario with taxis, there are currently 22,000 of our quite well-known black cabs in London. In terms of alternative fuel vehicle black cabs, we've only got 5. There's 5 hydrogen fuel cell black cabs. There's no electric black cabs or anything like that at the moment. However, a press release just came out today regarding ULEZ, which is the new ultra low emission zone, which is, if any of you are familiar with London, that covers the congestion charge area and will be rolled out in 2020. And as I said, it's hot off the press today. And part of that proposal, but will be ratified later, is the capability, vehicles capable of zero emission capable vehicles, and we're looking at taxis that are zero emission capable, but that hasn't all been decided yet. So obviously things that we're exploring are aspects such as rapid charging, 50 kilowatt rapid charging, and inductive charging for opportunity charging purposes. To give you an idea of a scenario that we've been looking at, which may be quite a good one for inductive charging, is feeder parks at places like Heathrow Airport. So that's basically where you have, before they get to the rank outside the terminals, they have to drive in and process themselves through here, where they move incrementally along these lanes before they head off to the terminal. Now all taxis have to go through that process, and they can be in that, busy times they can be in there for like 2 to 3 hours. So obviously, as you can imagine, you could have a semi-dynamic process for charging the vehicles. Obviously that would be contingent on space available. We have that sort of situation for the London area. We have that sort of situation at Heathrow Airport and also London City Airport, which is more central. Obviously it may be a little bit problematic for places like train stations unless it's a new build train station, but you know, it's something to be considered. Obviously the concept would have to include integration with diesel taxis as well, and to decide how that would work with diesel taxis and how you would incrementally roll out inductive charging facility such as that. Okay, with vans, the current scenario with vans in London is that Transport for London estimate there's about 220,000 light goods vehicles within London. There are about 700 LPG and 270 electric vehicles which are in commercial operation in London also. Some of them use Source London. As you can see, that's Boris Johnson, our current mayor, and he's standing there with some of the Source London charge points. There are 1,400 Source London charge points around London, a lot used by private individuals, but we do have quite a number of corporate accounts as well, so which service those 270 vans, but also commercial cars as well. One area that we're looking at for the rolling out of inductive charging is shopping centre locations. There are obviously quite a few within London, but 2 very large ones are Westfield London and Westfield Stratford City. Both of them worked in partnership with us to develop their electric vehicle charge point facilities, and they have 60 Source London charge points. As you can kind of see there's some of them between them. So we're looking at the opportunities with our freight and fleet department to install wireless enabled charging spots to service vehicles for a collection of shops, so that when a vehicle turns up to deliver, then the delivery operative can go off and make their deliveries and come back and they've got a charged vehicle. One of the advantages with this sort of situation with Westfield is there's fewer stakeholders involved. One of the main issues with London that we have is that, and we found when we were rolling out the Source London network, is London has the Greater London Authority, which is where Boris Johnson, the mayor, sits, but that has limited executive power over the 33 separate boroughs. So you can imagine there's a huge amount of stakeholders involved in trying to develop a cohesive citywide network of anything in London. So therefore, if we're trialling new technologies, it's definitely the way ahead, it's considered in London, is to work with private partnerships with organisations such as Westfield, because they've got the power capacity and they've also got the enthusiasm for new technologies. Quickly talk about London's power grid. As you can imagine, like a lot of large cities, London's grid capacity is at saturation point at the moment. Networking improvements are only reactive. They can't make speculative upgrades. So therefore, say for example, if with that taxi feeder park at Heathrow, if we wanted to electrify the whole park, it wouldn't work. We would have to do it incrementally and slowly, and it would take a matter of months and years basically to build upon that, because it is something that we have to completely, fully demonstrate any sort of power upgrades within London. And they have to be demonstrated to be benefit for all network users. It can't simply be a case of upgrades will occur in local substations, for example, just for one initiative or project. It has to be flexible. Any upgrades have to be flexible enough to serve all users in a region. Some mitigation strategies that we've been looking at is the analysis of grid loads against EV user patterns, but that obviously is something that value will be added to that with the more EVs that are used in London. Grid balancing through localised smart grid management is something that we're looking at, and we're working quite closely on a few other projects with, well, we have input along with the Greater London Authority into discussions with electricity service suppliers. Locally generated renewables are something, wind, solar panels, etc. I know that other countries such as Germany and regions such as Scandinavia are quite a few steps ahead of the UK with regards to those sorts of things, but it is something that we're pushing in the direction of. Okay, lastly, looking at the buses scenario, is there's about 8,700 buses serving 700 routes in London, which are managed by Transport for London. Services are run by more than 10 private operators. Contracts and scheduling is managed by Transport for London. Currently, we do have quite a large proportion of hybrid buses, 1,200 hybrid buses. And since the last year, we've had 8 pure electric buses running in central London, also 8 hydrogen fuel cell buses operating within London. And obviously for high utilisation vehicles, which like London buses, which have 15-hour duty cycles per day, opportunity charging, such as inductive charging, is seen as key to actually getting more electric buses, pure electric buses, into that 8,700 number. The wireless charging project that we're involved in, which is FP7 Zeus, we are going to demonstrate from October. It's going to launch, and it will last for 2 years. 3 plug-in series hybrid range extender buses, which will have 100 kilowatt coils. They'll be charged by 100 kilowatt coils. The infrastructure is going to be installed in TFL bus stations. This is so that we can control the environment. So we have very low footfall in the areas where those buses will receive their charge at either end of the route. So each time they go backwards and forwards, they will stop and they will pick up some extra charge. The objective of this project is to operate on grid electricity as much as possible, so at least 80%, if not more, of the time. And obviously, as we've said, they're range extended because we can't have, this is a live bus route, and so therefore we can't have any impact at all on operations, and we can't have any impact on obviously our customers, so therefore we've got to make sure that these buses are resilient. But as I said, hopefully 80% of the time they'll be running on grid electricity. That's the route in London. If that's the whole of Greater London, Central London's the middle bit. It's just on the edge of Central London. It's a route in East London that's, I can give you a few stats about that. It's 11 kilometres long. It takes about 40 to 50 minutes. The layover time, so the time at each end, is up to 15 minutes, but can be as little as 5 or 7 minutes, depending on the time of day. PVR, which is peak vehicle requirement, means that it has 15 to 18 vehicles running on that route at any one time. So one of the big issues around interoperability for us is not so much technological interoperability with the charging infrastructure, but interoperability between the 3 electric buses and the other 12 to 15 diesel buses, because they've all got to have that layover time. They've all got to sit on those stands for their given layover period. And so therefore it's making sure that we optimise the amount of time that the buses are picking up their charge, but whilst not interrupting the flow of the actual duty cycle for the whole service. And they're busy and congested stations, both stations at either end, Canning Town, which is just above the Docklands area, you can see on the map there, and Walthamstow Central are big bus stations, and they're built right on top of all next to London Underground stations. So there's a huge amount of infrastructure already there and a huge demand on the power supply there. So they're located in controlled environments, as I've said. The inductive power transfer is initiated automatically. There's about a 15 centimetre air gap, and the vehicles will be aligned by a camera under the bus and a visual aid, which will be basically a post next to the driver where the driver stops. Obviously the infrastructure is pretty solid, and then there's the external requirements which we're able to keep away from public areas, which will be the heat exchanger system and the control units. So in conclusion, from TFL's point of view, inductive charging has the potential to provide opportunity charging for these high utilisation vehicles, which will especially be pushed on by a very powerful policy driver like the ultra low emission zone, because it's going to affect, we're already making moves with regards to the buses, it's going to affect taxis, and it will affect eventually commercial vehicles also. Obviously trials and demonstrations are there to gain experience, knowledge and confidence amongst TFL and also its suppliers and operators. And the infrastructure requirements, investment and competition amongst manufacturers to keep prices down are key to future solutions, as well as grid capacity issues, technology standardisation, as we've already discussed. And as I've said, one of the main themes for TFL is strong public-private sector enterprise partnerships are key to kickstarting the acceptance of these new technologies. There's fewer bureaucratic restraints to trials and demonstrations, because as we've said with our previous experience with rolling out the Source London network, it's a very, very slow process dealing with the 34 bureaucratic organisations that make up the whole of London. And so therefore, when we can work with private partnerships, then we do everything we can to make those work. That's that. Hope that was interesting. No? Cheers. Cool. Sure.
One thing I didn't fully...
Do you want me to go back or?
capture, no, it's... today you have hybrid buses, right?
Sure.
And well, I've been riding some of them last year, so it's most of the time you trigger the IC engine. So your target is to minimize the non-zero emission or operations of the vehicle, right? Now, so you will set up kind of plug-in hybrids, but what is the actual benefit of wireless versus cable? Because you could recharge them with cable on both sides.
Because the amount of time that any of the hybrids, even the latest hybrid buses that we're using operationally, is not 80% on battery but on grid power. And so therefore, these buses for this project will be plugged in overnight at their bus garage. So they will leave the depot in the morning with 100% battery charge. And then obviously throughout the day as it drops, it picks up charge on the charge points at either end of the inductive charge points at either end. So therefore it's to increase the amount of time they can run on battery charge.
My question for maybe it was the right.
Sorry.
What is like both ends of the line.
Sure.
What is the strong benefits? I mean, value for money of investment.
Sure. As opposed to the driver getting out and plugging in.
Yeah.
Because
he has 20 minutes waiting. So wait.
well, it doesn't really. Well, this is the thing, is because they don't have 20 minutes waiting. The 15 minutes is quite hopeful that they'll have at each end of the line. Sometimes it's a case of they can have 4 or 3 minutes, and that time is crucial for the drivers to be able to get off, refresh themselves, other duties, etc. So we operationally we don't want to add anything to their obviously the great appeal of inductive charging. We don't need to add anything to their operational duties, and also it would be very Transport for London's bus drivers are very unionised, and the idea of getting them to have any other extra duties to do.
Okay.
Sure, yeah, exactly.
And at both ends, the process is the bus has to remain on the same position, or he can move, like you say, there's a kind of flow of buses, which is...
No, bus stands tend to work when they're waiting at either end. They have a specific bus stand that they will just sit on. But the thing is, then they've got to move off as per the schedule for the next bus to come along, and that could be a diesel bus. It's static. It's static because the driver can get off, switch off the vehicle, and leave, go to the bathroom, go and get some food or whatever, and come back. But then they have to make sure that they're moving off according to schedule for the next diesel bus. If it's a diesel bus, as the next one's comes along, and the same things happen. We've looked at options like, for example, sometimes having a diesel bus hop over the MISA term, but it's just not feasible in terms of the manpower involved. It's just not going to happen. So therefore we have to make sure that they pick up as much charge as that time as possible. So therefore, if there's, as it comes in and parks, it picks up the charge immediately. If we envisage having a driver get off and having to plug in a cable, then remember to come back and unplug it, and those sorts of things, as it's not really considered feasible. It's not as opportune as we would, as we would like. So this is why this is appealing to us. Okay, no worries.
Voor de audience, voor de kanaal van